Welcome back. Today we will learn how to rank intermolecular forces. Intermolecular forces are forces that exist between molecules. There are 4 types of intermolecular forces. The strongest intermolecular force is ion dipole. Ion dipole is when an ion interacts with a molecule that has a dipole. An example of this is sodium dissolved in water. The second strongest intermolecular force is hydrogen bonding. Hydrogen bonding is when hydrogen is directly bonded to fluorine, oxygen, or nitrogen. This is an example of hydrogen bonding because the hydrogen is directly bonded to the oxygen. This is also an example of hydrogen bonding because the hydrogen is directly bonded to the nitrogen. After hydrogen bonding, the intermolecular forces become weaker. The second weakest intermolecular force is dipole-dipole. All polar molecules have dipole-dipole. So any molecule that is polar, such as H2O, has dipole-dipole as an intermolecular force. The weakest of all 4 intermolecular forces is London dispersion. All molecules have London dispersion. If a molecule is nonpolar, then the only intermolecular force that it has is London dispersion. NH3 is a nonpolar molecule. Therefore, the only intermolecular force that it has is London dispersion. CH4 is also a nonpolar molecule. That means that the only intermolecular force that it has is London dispersion. Now that you know the order of intermolecular forces from strongest to weakest, you should be able to rank molecules based on their intermolecular forces. Here's an example. In this question, you have to list all intermolecular forces that apply to this molecule, and you have to state which of the forces is the strongest. H2 is a nonpolar molecule. That means that the only intermolecular force that it has is London dispersion. And since London dispersion is the only intermolecular force, it is also the strongest. CH2O is polar, and since it is a polar molecule, it has dipole-dipole. It also has London dispersion because all molecules have London dispersion. However, dipole-dipole is the strongest because dipole-dipole is stronger than London dispersion.